1 second exam,
One week?
and then the final exam. That's it.
Oh. Okay.
It's all in the syllabus. Got to remember to read that. Because you told me that you know where to find it already, that you have managed to.
Yeah, I just lost track how many tests we had.
It's in the syllabus.
Okay.
It is in the syllabus. That's why I wrote it.
Okay.
All right. Well, let's go ahead and get started. So what we'll do today is we'll go over the homework assignment that was due like a minute ago. And then we'll go over the practice questions for exam 2, which is scheduled to be the Thursday after the spring break. Okay, so we have about 2 weeks, from today. But since spring break is 1 week, so practically it's only 1 week from today. So whether you use a spring break to study or not is entirely up to you. I would spend some time to study, just to kind of keep that content in, because if you don't touch it for a week, a lot of this content will be lost.
Notes? No notes.
Sorry?
Bring your own notes.
It's open book, open notes, just like with the first one.
Okay.
And I'll bring my calculators. All right, so the homework assignment is array 2, and I gave you an algorithm that is intentionally flawed so that you have to fix it. Okay, so we'll go ahead and take a look at how flawed it is and how we can, fix it up. Well, not fix it up, but to what it does. Yeah. Maybe that would be a good example too, is to kind of give you a flawed algorithm, tell you what it is supposed to do, and then have you guys fix it. But not this one. Okay, this one that you're not supposed to fix it. You just have to trace it and tell me, what it's going to do. Okay. All right. So we know that there are some infinite loops involved here. We just don't know how bad it is. How bad this program is. In other words, how many of the test cases will give you or get you into an infinite loop. So we'll take a look now and see whether we can trace it and answer those questions. And I think this one can be a little bit narrower. We'll see. Okay, so here's the precondition, and then we start with line 1. Line 1 is initializing b to 0. Line 2 is initializing e to bar a bar minus 1. In this case, there are 4 elements in a, so bar a bar is 4, 4 minus 1 is 3. Then we go to line 4. We do not trace line 3. I'm really hoping that nobody is tracing line 3, because I explicitly said do not trace line 3. So we get to line 4. Line 4 is just computing b plus e divided by 2 and then take the floor of that. b plus e divided by 2 is 1.5. The floor of 1.5 is 1. It is the largest integer that is less than or equal to the number. So in this case, it is 1. And then we move on to line 5. Line 5 has a condition to evaluate, so we have to put it into the comments section. It is comparing a bracket m to k. A bracket m is a bracket 1 because m has a value of 1. A bracket 1 has a value of 6. 6 is greater than 9 is false. And because this is not a multi-branch conditional statement, it just has an else. So we go to line 8 right away. And line 8 is just copying the value of m to b. M is 1, so b is now getting a value of 1. After line 8, we get out of the conditional statement. The conditional statement is the last statement in the post-checking loop, so we get to line 10 right away, and then we have to evaluate a bracket m equals k is false. We already know that part because we did a comparison before. It is actually less than. A bracket m is 6. 6 is less than 9, which is the value that we are looking for. Since the first part is false for a disjunction, we have to evaluate the second part. B has a value of 1 at this point. 1 is greater than E, which is 3, is also false. So we have false or false, which means the answer is false. Then we have to go back to the beginning, going back to line 4. Line 4 is going to take a look at the value of B, which is now 1. It will take a look at the value of E, which is now 3. 1 plus 3 divided by 2 is 2. So this time we update the value of M to become 2. Are there any questions at this point? questions? All right, let's move on. Then we move on to line 5. Line 5 is comparing A bracket M, which is A bracket 2 in this case. It has a value of 8, and it wants to see if it is greater than K, which has a value of 9. The answer is false again, because 8 is greater than 9 is false. So we go to line 8 one more time, just like last time. And line 8 is going to copy the value of M into B. M currently has a value of 2, so B ends up with a value of 2 as well. And then we get out of the conditional statement, we get to the end of the post-checking loop. So we check again, A bracket M equals K is false, B is greater than E is false, so the entire thing is false. We have to go back to line 4 again. When we get back to line 4, 2 plus 3 has a value of 5. 5 divided by 2 is 2.5. The floor of 2.5 is 2. All right? So we have, M is updated to a value of 2. Then we move on to line 5. We are once again comparing A bracket M, which is A bracket 2, with K, and see if it's greater than it. And the answer is false, because we have not really changed the values of anything. And then we move on to line 8. Line 8 is just copying the value of M into B. M has a value of 2, so B ends up with a value of 2 as well. We get to line 10. The overall condition is false. And we can, basically at this point, we can conclude that it's an infinite loop because we have gone through exactly 2 iterations with exactly the same values stored in our variables. So that means, the next iteration is going to be the same. Okay, nothing is going to change at this point. Yep.
That's because of floor, right?
It's not because of floor. The floor function is correct. It is because of the conditional statement from line 5 to line 9, and also because we are not using M minus 1 and M plus 1. So there are quite a few reasons why this program is not working the way it's supposed to. But mostly it's because, E is not getting M minus 1 and B is not getting M plus 1. That is the main reason. Yep.
So on line 2, when bar A bar isn't given a value, how do you find out which one to use?
Sorry, say again?
On line 2, when it says E gets the value of bar A bar minus 1, since bar A bar doesn't have a number,
it does.
Bar, which one do you use?
What is the meaning of bar A bar?
The number of.
And how many are there? Oh, you just answer your question. Okay, very good. All right, so this is the test case number 1, and it is not going to work because it gets into an infinite loop. So now we move on to the test case number 2 and see what happens with this one. With test case number 2, it's we changed the value of K, so instead of 9, it now becomes 3, which is also a number that does not exist in the array. So the first part is kind of boring because we're still initializing B to 0, and we're still initializing E to 3. So because I haven't really changed anything except for K itself. So now we move on to line 4. Line 4 wants to compute B plus E divided by 2. Same thing as last time. So we have 0 plus 3 divided by 2, which is 1.5, and the floor of that is 1. We move on to line 5. A bracket M is A bracket 1, which has a value of 6. 6 is greater than K, which has a value of 3, is true.
Now, if you said, instead of floor, you said roof.
What?
Instead of floor and you said roof, would that be 2?
Ceiling. There's no
ceiling?
roof. Ceiling. Close. If you use ceiling, it becomes 2 instead of 1. Okay, on line 6, we copy the value of M to E this time, so E ends up with a value of 1, and then we get out of the conditional statement, we get to line 10. A bracket M equals K has to be false because we just did that comparison, and then E at this point has a value of 0, E has a value of 1, so that this condition is false as well, so we have false or false, which is false. And then we go back to the beginning of the loop again. This time we have to recompute the value of M. It becomes 0 plus 1, which is 1, divided by 2, which is 0.5. The floor of 0.5, we just talked about that at the beginning, is 0. So M is now getting a value of 0. We move on to line 5. A bracket M is greater than K. This time is false, because A bracket M is A bracket 0, and it has a value of 2. 2 is greater than 3 is false. we move on to the else case, which is on line 8. On line 8, we copy the value of m, which is now 0, to e, so e also ends up with a value of 0. And then we continue on to line 10. A bracket m equals k is false, b is greater than e is also false, but we cannot conclude that this is an infinite loop at this point because, over the past iteration, some of the values changed. Yep.
I think the value only meant was e instead of b with 0, because line 8 deals with.
Oh, b, sorry. Yep, thank you. Thank you. So this gets a value of 0. But even at this point, I cannot really make a conclusion. Most of you can probably see that, because b and e have not changed, so that means, m is going to end up with the same value in the next iteration. But since I told you guys that you have to kind of observe 2 iterations of no value changes, so we still have, one iteration to go before we can make that conclusion. So we get back to line 4, and this time.
Professor?
Yep.
How did you get that 0?
Say again?
How did you get that 0?
Which one? This one?
Yeah, both of them. I mean, on line number 4.
Okay, are you talking about this one?
Yeah, number
which
10.
row? This
Yeah,
row?
Yeah.
Because 0 plus 1 is 1. 1 divided by 2 is 0.5.
Oh, yeah.
The floor of 0.5 is 0.
Alright. Okay, thank you.
And this 0, we get it because we copy it. So we are now back to line 5. So line 5 is going to do exactly the same thing as last time because m has not changed. So this is once again false. And then we get to line 8. And line 8 is going to copy the value of m to b again. So that's once again 0. And then we go to line 10. And it comes to the same conclusion. The exit condition is false. And at this point, you can conclude that this is an infinite loop because we have observed 2 iterations with no real changes to the values in the variables.
Couldn't you argue though, if you didn't go through the last iteration that we did, you're already at, a bracket 0,
Yeah,
and you couldn't.
You can argue that.
Because you couldn't go any further back, up the chain.
Well, you can argue that because at the beginning of the loop, you can see that the values of b and e have not changed because m depends on b and e. So as long as b and e are not changed, m is going to end up with the same value as the previous iteration. So you don't really have to go that far, but as long as you can still make the conclusion that it is not going to change from this point on, it will still be okay. Are there any further questions about this one? No? Okay, all right. So let's move on to the last one and see if we have any better luck this time because 6 is inside this array here. And this is of course a trick. This is the quick one. Okay, this one is not going to take you a lot of time. Okay, because on line 1 we once again initialize b to 0. On line 2 e gets a value of 3. That part has not changed. On line 4 we compute the value of m, and once again it is 1. And then on line 5 we make the comparison. A bracket m is a bracket 1 has a value of 6. K also has a value of 6. So technically speaking, this is false. Right? I mean, we have, 6 is greater than 6. This is false. So we have to get to line 8. Line 8 is copying the value of m, which is 1, to b. So b also ends up with a value of 1. And then we get to line 10. On line 10, a bracket m is a bracket 1, which has a value of 6. K also has a value of 6. And using short-circuited evaluation, that's all you're going to write. Because if the left-hand side of the disjunction is true, then the entire disjunction is going to be true, and so we don't have to evaluate the right-hand side. Okay, because I'm pretty sure that I said that we have to use a short-circuited evaluation after that topic was introduced, so that's why this is what I'm expecting. If anyone gives me the entire expression and say it is true, I will not take all the points off, but I will take some points off because that is important. All right. Are there any questions about the third test case, which is the easy one? Nope. No questions. All right. So if there are no questions, we'll move on and talk about the practice exam. All right. So I have decided to change, the way I put the way I ask questions in the exam. Instead of asking you to give me a full trace, I'm asking you guys to give me just numbers. Okay. So I'll be grading based on just the end result or the observable part of the algorithm, but not so much the tracing. Which does not mean that you don't have to do any tracing. It simply means that I'm not going to use that part for grading purposes, because that's what taking so much time is. I have to go through the entire trace. Now there are two cases that are easy to grade. Okay, either no answers, okay, that's an easy one to grade, or it is completely correct, because I can identify something is completely correct just by checking it against the key. That's easy too. But the problem is, what if there's a problem in the trace? Okay, in other words, certain steps are done incorrectly. Then it becomes kind of difficult to assign partial credit, because it all depends on when that problem happens. So instead of doing that, if you look at the practice questions, the new one, it's a little bit changed from before, but I think it's not going to be that bad. Especially for people who do not really like the tedium of tracing, and they say, okay, but I can keep track of all this stuff using my own way. I don't need to trace it using the same type of method that we talk about in class. You know what? In that case, this will work, to the advantage of those people. All right. So this is the format of the test. I'll give you questions. Probably more than 4, because you don't have to waste the time to actually do a full trace anymore. You don't have to kind of really write down everything in a legible way, except for what is going to do the underscore part. All right, so this question is a recursive algorithm. Oh, okay, before we do this, I forgot one other thing. The new homework assignment. Yeah, there's a new homework assignment, because I want you guys to have the practice before the exam to kind of deal with subroutines. So you have a new homework assignment under topic 7. And it has the name of sub 1. So this is your new homework assignment. And if you look at the homework assignment and look at the question that we're talking about today, even though this time I'm giving you 12 days to do it. Okay, including the spring break, you have 12 days to do it, which means it's due on the Tuesday, not the Thursday after spring break. Okay, but there's a reason why I think it is not unreasonable to have you guys do it in one day. Because if you look at the code in your homework assignment, this is your homework assignment, and this is the exam question. Okay, let me try to display these side by side so you can take a look and say, do you see any resemblance?
Yes.
Okay, well, there you go. So after we talk about the exam question today, I don't think the homework assignment will take you that long to do. I mean, it's really just a matter of typing stuff, putting into the spreadsheet, but not as much in terms of concepts, because it is going to be very similar in terms of concepts with question number 1 in the practice questions. Okay.
Did we do this similar 2 days ago?
Sorry?
Did you do this?
I
Oh,
did
it's
something
invoked.
like that 2 days ago. So that's
why it's
even
like-
more reason why the homework assignment should be doable in the next day or 2. I mean, just get it done before spring break, then you don't have to worry about it. All right. So this is the question, a question for practice questions. This is a practice question for exam 2, and I want you to tell me what is the value of x on line 10, and then also tell me the value of x on line 10 after the invocation is done, immediately after the invocation is done. That's the question. That's what it's asking. Okay. What do you think? Do you guys want me to trace it to answer these questions, or do you think you can probably figure this out without tracing it?
I'd rather trace it.
Rather trace it?
That's the only way
Mhm.
I know. I mean, I might be the only one.
Nope, but tracing it is the safest way, okay? Because you're not gonna miss anything. That's the whole idea of tracing. Is it becomes kind of difficult to miss anything. So let's go ahead and trace it. In this case, I'm going to copy the algorithm first. Okay, so we have the define sub xyz. If x is greater than 0, then x gets x minus 1. Invoke xyz. This is the recursive part. It is invoking itself. Y gets y times 2. Else y gets 1. And if and define sub, invoke xyz. Alright, so let's go ahead and fix the indentations first. Okay, I'm gonna cover the other side now because there's no need for the other side to display anymore. Let's fix some indentations and we can start the tracing right after this. Oh, there's another thing. The other thing has to do with the notes. When you're studying for this class, in topic 7, most of the topics, unfortunately, were not really working. But the last one is the one that you need. Okay, this is the updated subroutine notes is actually the one that I think is the best one. So even though the other links may be useful, but the last one is basically the one that is most helpful. I think most consistent with the way I'm teaching it now. So that's why just click on the last one, and that one should work because I think I checked that one. There we go. Okay, now getting back to the trace that we are going to do. Right, so here's the algorithm, and the trace is based on x starting with the value of 0, x starting with the value of 2, and x starting with the value of 4. Okay, so we'll go ahead and take a look at all of those test cases. Each one has its own spreadsheet. Now, since the question types has changed, I'm not going to give you the space to do your actual tracing, so you will need to bring your own paper in order to write your trace, because some people do not need to trace it. Some people can look at the algorithm and figure out what it's supposed to do, and some people want to do a trace just to be sure. I mean, there will be enough time to do a full trace. I mean, it's just that you don't have to turn it in. It's not going to be used for grading purposes. All right, so let's look at sheet 2, and this is going to be the first one. We do need one column for comments because there's a conditional statement starting on line 2. Then we have line number, and then we have two variables, x and y in this case. All right, so let's shrink those columns. And the precondition is important now because in the question, let me just go back to the question for now. The question says, compute the values of y given the following initial values of x on line 10. So in the first case, x starts with a value of 0. So that corresponds to the precondition, x starting with a value of 0. Y is still unknown because I didn't tell you what value y is supposed to be starting with. And then if you look at the algorithm itself, we are starting on line 10 because line 10 is the first line and the only line that is outside of the definition of a subroutine. That's the line that we are starting with. And it's an invoke statement. For any type of invoke statement, we allocate a column, the leftmost available column, and then label it return line number, just so that we can remember where we are supposed to go back to after this invocation. In this case, it is post, because line 10 is the last line in the entire program. After you remember where you're supposed to go back to, now it's time to get into the subroutine starting on the first line of the subroutine, which is line 2 in this case. Line 2 evaluates the condition, x is greater than 0. This time it is
False.
false. Very good. And since it is false, we have to go to the else branch. The else branch is line 7, and y is getting a value of 1 in this case. And then we are done with the conditional statement, so we can jump to line 9, which is the end of the subroutine. At the end of a subroutine, you have two things to do. The first one is to locate the rightmost active return line number. In this case, it's column E. So this is column E, and column E tells me to continue execution and post. So I will make a note and say that I'm supposed to go there next, but after I make that note, I also have to remember to deallocate the column. In other words, I have to mark this column as not being in use anymore. So I will do a strike through, single strike through, and that's it. So in the question, I can also ask you, Okay, even though it is not asked in the practice question here, I can also ask you up to how many columns are allocated and deallocated in the process of running this algorithm. So in this case, it's 1, okay? Because columns A, B, C, and D are always there. So they are not allocated and deallocated. Column E is the only one that we allocated and then deallocated later on. So the answer to that question, if I ask you how many columns are dynamically allocated and then deallocated, in this case, it's just 1. Are there any questions about the first test case here, when x starts with a value of 0? Okay, let's see what happens when x starts with a value of 2. Okay, because that's the second test case. So with the test, okay, I will just be a little bit lazy here because I can copy and paste some parts of one spreadsheet to the next, and I just need to erase the rest of it and change the value of x to 2 to begin with. All right, so same thing, we start execution on line 10. It is still an invoke statement, so we reserve the leftmost available column to make it our return line number. Line 10 is still the end of the entire program, so when we come back, we should go to post, and then we continue execution in the subroutine starting on line 2. But this time, x is greater than 0 is true because x starts with a value of 2. So after this, we have to get into the then portion of the conditional statement. On line 3, we're just subtracting 1 from x. X goes from 2 to 1, and then we go to line 4. On line 4, we're invoking again. Every time you invoke, you're doing exactly the same 2 steps. Allocate the leftmost available column, in this case it's column F, mark it as a return line number column, and then you have to remember, where am I supposed to come back after this invocation of XYZ? The answer is line 5, because the invocation is on line 4, so when it is done, it is supposed to continue execution on line 5. So that's what you write down here in column F to remind yourself and say, when I'm done with this invocation, I need to go back onto line 5 and continue execution. But after you remember where you're supposed to go back to, then you have to go to the first line in the subroutine. Even if this is coming from the same subroutine, every time you invoke, you just go to the beginning part of the subroutine that you're invoking. So in this case, it is line 2, and line 2 has a condition to evaluate. It is still true because x has a value of 1, so 1 is greater than 0. So we go through pretty much the same thing. We go to line 3, x becomes 0 in this case, and then we go to line 4. And this is going to get a little bit boring because we have to allocate the leftmost available column and then remember where they're supposed to go back to. And then we go to the beginning part of the entire subroutine, XYZ, which is on line 2. Except this time, x is greater than 0 is going to be false because x is 0 already. 0 is greater than 0 is false. So we have nothing to do in the then portion anymore, but we do have an else portion of this particular conditional statement. So now we have to go to line 7, which is the else portion of this conditional statement, and that is how y is getting its value of 1. Because y started off with an unknown value, but at this point it becomes a value of 1. After we are done with line 7, we get out of the conditional statement, we get all the way to the end of the subroutine. And then we have the 2 things that the end of a subroutine has to do. First, locate the rightmost active return line number. In this case, it's column G. Column G tells us to continue execution on line 5. So we put a 5 here just so that we remember to do it. And then we go back to column G and then say, okay, this column is no longer in use anymore. So instead of deleting it, I'm just going to format cell and do a strike through to indicate that this is no longer in use. Now I'm continuing execution on line 5. Line 5 says, double the value of y and then store it back into y. Fine. Y has a value of 1 at this point, double that, it becomes 2. And then after line 5, I'm done with the then branch, so we get out of the conditional statement altogether, and then we get to the end of the subroutine on line 9. Same thing, locate the rightmost active return line number. It is not column G anymore because it is now deallocated. So now it's column F. It tells me to continue execution on line 5. Make a note of that. And then we have no use of column F at this point as soon as we make that note. So we have to remember to indicate that this line is no longer needed. Now we continue execution on line 5. Line 5 is still doing what it used to do, okay, except the value of y has now changed. So we're doubling the value of y again, which is 2 times 2, which is 4. So we
Okay.
put a 4 here. Yep.
Before you start going further, if we're not gonna trace the beginning of the subroutine, why are we tracing the end of it?
We're not tracing the beginning of a subroutine.
Be, line 1 is the definition of the subroutine,
Right.
and line 9 is the end of the subroutine, right?
That is because the end of the subroutine actually has something to do. The beginning does not. In other words, define
it
sub
doesn't.
xyz is nothing more than just a notation to say that this is the beginning of the subroutine. But the end of the subroutine actually has 2 important things to do. So that's why we have to trace it. Because if we don't trace line 9, then we can no longer keep track of which column is deallocated and which one becomes our rightmost active return line number. Yeah, so that's why line 9 is actually important, even though it doesn't seem like that. Okay, so on line 5, we are doubling the value of y, which is 2 times 2, it becomes 4, and then we get to line 9 again. And once again, line 9 is going to locate the rightmost available column, which is column E in this case. Excuse me, the rightmost active return line number, which is column E. It tells us to continue execution at post. And then after we make that note, we can say that column E now is not useful anymore. It is now deallocated. And then we continue execution at post, which means we are all done. Okay. So are there any questions about this trace as opposed to the first one? Go ahead.
So then,
Oh,
So then we gotta put 4 as the value of y.
that is correct. 4 is the value of y when the invocation is done. That's correct. Go
That was
ahead.
my question.
Yep. Oh, okay.
That was-
All right. So in this case, it's 4. In the previous one, it's 1. Do you want me to do the last one because it's going to be a little bit boring? It's about the same. Yep.
I just have just like a general question. Anybody can answer this. I hear you say that you're not gonna have us trace on the test because it's easier, but does anybody see the easy in it? Like, I don't see the easy in it. I can't look at it and say, okay, that's what y is gonna be. So I'm wondering if anybody else can, because if so, then I feel like I'm not learning and I need to study more.
Well,
maybe.
you don't have to compare yourself to the rest of the class. You know, I think tracing is the safer way to do it. So I would definitely, you know, if I were you, you know, and I already know how to analyze the algorithm, I would still trace it.
Me too.
Okay, you know, just so that, you know, I know exactly, you know, what the algorithm is supposed to do, because, you know, what if I throw something here and, you know, it is not doing what apparently it should be doing? Well, you should always trace it then.
Could you go back to sheet 2?
But some people like to shortcut things, like they have stuff to do at 10 o'clock, or they want to leave as early as possible. So some people may decide, okay, I will just, you know, try to analyze the algorithm and keep track of stuff in my mind so I can get out of class earlier. So don't get worried if someone says, you know, I'm not going to trace it. I know what the answer is, because tracing it is the proper way to do it. Did I address your question? Okay, very good. All right, so with the last one, okay, the trick about this is, go ahead.
Could you go back to sheet 2? I just want to take a look at something.
Go back to sheet 2.
Yeah, I just want. Oh, okay. Mine.
Okay, now this is important. Okay, when you look at sheet 2 and you look at this portion here, okay, do you see that sequence in sheet 3?
Yeah.
It is, right? So that means, you know, when you are tracing it when x equals to 4, if you do the entire thing, it's going to take a while. But you will find that once you get to a certain part, it becomes, quote unquote, the sub-problem that we have already done in sheet 3. Okay, you guys are not.
Sheet 4 is going to be 8 then?
Sheet 4, it's not going to be 8. See, you are trying to work it out in your mind, which is okay. I mean, this is just a practice test, you know, but you're trying to work it out in your mind. It's not 8, you're close. I think you know the general pattern of it, but you're off by 1. Not off by 1 like 9, but you're off by 1 by missing 1 invocation. Each invocation is doubling. is 16. Yep. So if you're not convinced, I would advise that you do your trace, for this one, when x equals to 4, just trace through the entire thing and see if about 1/2 of sheet 4, when x equals to 4, is really the same thing as sheet 3, which is when x equals to 2. Okay, so to do that and see if you can see that, oh, okay, so when x equals to 4, there are only like 2 invocations that are unique, and then after that it's the same problem that we have already solved in sheet 3. So that's something that you should probably do, because it will give you an idea of why recursion is so useful, because there are, once you figure out when a sub-problem or smaller one, the bigger one is now becoming just, okay, we have to do certain steps in order to reduce the problem to a smaller problem. And then the smaller problem is just like before. Yep.
How many columns of allocated and
Ooh.
disallocated? 3?
Okay, is it just me or do you guys see?
No, it's
Okay.
green.
funny.
It's usually, funny color. I wonder if it has anything to do with air circulation here. We're all seeing colors. Ugh. Let's see. Sometimes it's just the connector not working correctly. It's not helping. Okay, so now we have to find the connector. There we go. It's this one here, and it's not plugged in correctly. So I'm going to fix that problem once and for all. No, I'm not going to solder it. Some people say that, Tech, do you have a soldering iron in your pocket thing? Not quite, but I could pack one here. I have a butane soldering iron. Comes in handy sometimes. do you guys know what is a butane soldering iron?
Yeah.
It's kind of like looks like a gigantic lighter, but instead of a flame at the end, it has a soldering tip. So it will heat up the soldering tip, and now you can solder stuff without an electrical cord, and it works pretty good too. But I'm looking for my screwdriver. This is they call this
Multi-tool.
it's a 10-fold. They call it a 10-fold, and what it has, is a tool like this, and then it takes out, and then each side, has 2 bits, so you can actually end up with 10 type of things that you can, fasten basically. Comes in pretty handy, and in a pinch, that can also be used as a blunt weapon. Okay, so now I can put this back in and make sure that it does not get loosened. Looks like I got the wrong bit. But think about, when I'm doing this, think about this project. Go ahead. You can still ask questions if you want.
I was just gonna ask, like, if there was on line 10, it says invoke XYZ, and then, let's say there was a line 11, and it said invoke XYZ, would we start on line 11 or 10?
Say again.
Like,
If 2 lines are both invoke XYZ, when you come back, let's say line 11 is invoke XYZ.
would that happen?
What do you think would happen if you do have a line 11? What would be different about this trace?
Well, I guess you would just say, you would start with line 10 and you would say return to 11, right?
Say again?
You would start with 10, just like here, and then you would say return, instead of post, like on the.
Correct.
Right,
Yes.
Instead of post, it would be 11, right?
That is correct.
Oh, so you wouldn't start at 11?
No, you always start with the first line that is outside of the definition of a subroutine.
So line 10, regardless of what's after it, is the first thing outside the sub.
Okay.
Is it because like the line 1 says, hey, these are the tools you can use until it says end define. It's kind of saying like these are your tools, and then you start on 10, and that's why you go back to using those tools. Right?
You mean on line 11? If we had a line 11 here?
No, just like what we have here.
Uh-huh.
Line 1, like when we first look at it, right? Line 1 is just says define subroutine, and then from line 1 to line 10, that's a whole entity itself, right?
Okay, from line 1 to line 9 is the definition of a subroutine. In other words, okay, imagine XYZ as wash dishes.
Yeah.
Okay, and then in that analogy, then line 2 to line 8 will be the procedure or the process or the steps that you have to take to wash a single dish. Okay, and then line 10 is actually telling someone to, okay, now that you know how to wash dishes, wash a dish.
Yeah, and then my question with that is, why wouldn't it be invoke XYZ on line 1, and then starting line 2 would have
Because the invocation can be anywhere. You can have invocations, anywhere within the algorithm. But the definition only needs to occur once. You only need to define or tell someone, the actual steps, the details of washing dishes once, and then you can tell that person to wash dishes whenever you think, dishes should be washed.
But it is, like, it would be the same thing if line 10 was actually before.
Oh, I see what you mean. Yeah, technically speaking, yes. But in this class, I always give you the definition first, just so that you know what it is before you invoke it. But yes, technically speaking, you can change the order and it should still behave the same way. Correct.
And then if it said invoke XY, let's just say XY instead of XYZ, and we don't have the definition.
Then we have a problem. Then you have to say that the subroutine does not exist and there's no way to invoke it.
Okay.
Yep.
How is it technically correct though if you haven't defined the variables?
Because it depends on the programming language. In certain programming languages, you can, when the compiler works, it works differently because it can look backwards. It can also look forward to look for the definition of a subroutine. Yep. It's typical that when I write Perl scripts, I would actually write the invoke first, and then I will actually define the subroutine later in the file. So you can do it either way. You can define the subroutine first, or you can invoke it and then have the definition later. Because the compiler or interpreter typically does not read things the way we do. It reads the entire file first, and then it goes back to the first line to execute it. Yep.
And how many columns of allocated in the other?
In this case, if you look at this one, there are 3 columns.
3. And
Yep.
the first one is 1.
The first one is 1, and this one uses up 3 columns, right? From this, can you tell how many columns the last one is going to take?
6. 5 or 6.
It'll be 5, not 6, 5.
Each time that's 2. Each time that's 2.
Each time,
That's 2.
I'm
no,
just saying 1, 3, 5.
1, 3, 5. That's
So
correct.
she's saying
Yeah.
adding 2. She's saying is there a pattern because
Yeah.
1 plus 2 is 3, 3 plus 2 is 5.
Well, that's because every time you get into the subroutine on line 3, okay, let's go to line 2 first. So every time you get into the subroutine, you check line 2 first, right? So line 2 says if x is less than or equal to 0, then you only need 1 column. But if x is greater than 0, the first thing we do is to subtract 1 from x, right? And then we do the invocation. So the number of columns that you need is basically the value of x plus 1. The initial value of x plus 1 is the number of columns that you need in this case.
What day is our test? What day is our test?
It's the Thursday after spring break. And I should probably take a roll now that we are at 43 past 9, so I think that would be a good time to take a roll. I think quite a few people are missing today because some people want to have a longer spring break. But today's class is actually important. Yep.
Can you go back real quick?
Oh, sure.
Yeah. And then the other question on the invoke. Invoke is kind of like a bookmark, right?
No, invoke is not a bookmark. It's going to a definition to do what the definition is telling it to do, and then come back and continue to do what else you need to do.
Yeah, because like line 4 is kind of confusing. But it says invoke. So from line 4 you go back to line 2. Like I'm looking at the trace now.
Yeah.
You go back to line 2 and you do that.
But that's what an invoke statement is supposed to do. There are
Go
two
back.
things. No, don't think about going back, okay? It continues execution in the first line, on the first line of whatever subroutine you're invoking. That's what it's supposed to do. Okay? So that's why I kept saying that, okay? When I trace this algorithm, remember I kept saying that? That's it. That's basically what it is, okay? When you invoke, you continue execution on the first line of the subroutine that you're invoking. In this case, it just so happens that you are already in that subroutine, but it doesn't change what an invoke statement is supposed to do. You still have to go to the first line of the subroutine that you're invoking. That is the key, is not to overthink it. Just think about what an invoke statement is supposed to do, regardless of where you are running the invoke statement. Yep.
Now, when you say invoke XYZ, does the XYZ stands for like a?
It's the name
parameters
of the
for-
subroutine. That's why there's a defined subroutine. It is an identifier.
But-
Okay, that name has to match. That's how you can find out where you're going to continue execution. Is the subroutine of the name that you're invoking.
But is there something? It has something to do with searching for parameters within a three-dimensional object or
No,
something?
has nothing to do with that.
Okay.
Yep. Okay, from the questions that you guys are asking, or some of you are asking, I think it might be helpful to read the notes too. And as I kind of talked about it last time, the first part of the notes, they're actually not gonna work. So the last one is the one that you need to look into. So click on this one and here, and then you can actually tell, all of this stuff is already discussed here. So this is one of the important part of, taking a class like this, is to read the notes. The lecture is one thing, but I'm already assuming that you have read some of the notes before class. You don't have to fully understand it before class because that's my job, is to go over that stuff and explain it to you. But you also have to read it again afterwards, just so that those concepts can sink in. Now, since I'm here already, I might as well show you some secret weapons that I have. That the ATF, is not interested in. Let's make it very clear. Not that kind of secret weapon. No, I do not operate my drones. Okay, so I can look at activity report or class participation. I think I want to look at, let's see, which one should I look at? Course participation is good. So I can basically look at each topic here. So I can look through all of this stuff here and look at where we are. Where are we now? We are in, these are files, URLs, and we are in subroutines. So where's the one that I'm talking about? Updated subroutine notes. Okay, so this is the one that I want you guys to read. So I can look back, let's say, I think we have been talking about this for about a week or so, and I can look at student participation and click on all actions and go. And the result is interesting because I can tell who has read it how many times. And I can show all 39 at the same time. And the result is not very encouraging because for the most part, very few people in the class has read that note. Okay, so that's why, and I think that is explaining why I'm getting questions that I'm getting today. Okay, so you guys got to do your part and read the notes. Okay, even though I have screen recording and all the other stuff, you still need to do some studying and reviewing. I'm not saying that everybody has to do that. I'm just saying that on the average, you are most people should be doing that. All right. Any questions about that part? Okay. All right. So I'm doing this with all my classes, because I'm seeing about the same effect with all of my classes, and I'm doing at a slower pace this semester compared to previous semesters. All right. Let's move on to question number 2 then. Question number 2 is does not have subroutines. I intentionally put this one, make this one without subroutines, just so that if someone really cannot do any subroutine ones, they can still get this one, hopefully. So this one has arrays. It has a mod operator, and I want you to read the algorithm, trace it on a piece of paper if you need to, and then answer the questions. The questions are, okay, let me just read the second part of the question. Assuming array A has 5 elements, what are the values in each element after this algorithm completes? That's what I'm asking. So I'm asking you what is in A bracket 0, A bracket 1, all the way up to A bracket 4, because remember, A has 5 elements. So go from A bracket 0 to A bracket 4. All right, so let's go ahead and trace it, because I do want to trace this one, just so that we know, what it's doing and, how it's getting it done. All right, so here we go. The first part is to copy the algorithm. So we got I gets 0, J gets 0. We have a post-checking loop starting with a repeat. And then I have I gets I plus 7. And then the whole thing mod bar A bar. Then we have A bracket I gets the value of J. J gets J plus 1 until I gets 0. Okay. And then we fix the indentation. I'm going to cover up the other part because the algorithm is copied already. And then give these things line numbers, and we can trace it. Now, when we trace something like this, you also need to write down, the number of elements in the, oh, that's the wrong one. Okay, let's get rid of that. There we go. All right, so let's go ahead and trace it. We do have one condition on line 7 to evaluate, so we need comments. We have line number, we have 2 variables, I and J, and then we have array A. Array A has 5 elements, so we have A bracket 0, A bracket 1, 2, 3, and 4. And let's go ahead and shrink the width of all of these columns so we can see all of them at the same time. All right, I and J do not need to have any specific value to begin with because they're both initialized on lines 1 and 2. So this is my precondition. The precondition is nothing really needs to have any specific value because they're all going to be initialized in the algorithm itself. All right, starting on line 1, I gets a value of 0. On line 2, J gets a value of 0. And then on line 4, we have to compute I plus 7 mod bar A bar, which looks kind of weird. It's like, wow, we're combining all these different concepts that we have picked out from different parts of this class. But that's okay. Do we know how to add I and 7?
Yeah.
Yep, go ahead.
Just really quick on 7. Doesn't matter if I equals 0 is in parentheses.
On which line again?
Line 7 until on the.
Oh, doesn't matter. You can put extra parentheses around it, or you can just leave it the way it is.
It would be helpful, right?
It depends on the programming language. Some programming languages expect that, and some do not. Okay, so getting back onto line 4, the right-hand side, I plus 7 is what? 0 is, well, I is 0, okay, is 7. What is bar A bar? 5 elements. So what is 7 mod 5? What is the remainder of 7 divided by 5?
7 divided by 5, 1.
2, that's right. Okay, very good. Okay, so the entire right-hand side becomes 2, so I is now getting a value of 2. Then we move on to line 5. Line 5 says, okay, the right-hand side is just J. J has a value of 0 at this point, and where am I going to store J? Well, I has a value of 2, so I'm storing J into column G because I is 2, so we are storing into A bracket 2. So A bracket 2 is now ending up with a value of 0. Moving on to line 6. Line 6 is just adding 1 to J, so J goes from 0 to 1. And then we get to line 7. Line 7 has the exit condition to evaluate. I equals to 0 is false, because I is now 2. Then we go back to line 4 and re-evaluate the right-hand side. At this time, I has a value of 2. 2 plus 7 is 9. 9 mod 5 is, what is the remainder of 9 divided by 5? 4. Very good. So we have I getting a value of 4, and then on line 5, we are storing 1 into A bracket 4. So column I is the one that is updated to a value of 1. And then on line 6, we just add 1 to J. J goes from 1 to 2. And then we get to line 7. I equals to 0 is false because it has a value of 4 at this point. Then we move on and get back onto line 4. Line 4 is recomputing the right-hand side. This time, if we have 4 plus 7, which is 11, what is 11 mod 5? 1, okay? So 1 goes into I, and then we go to line 5. A bracket 1 gets a value of 2. And then we go to line 6. Line 6 is just adding 1 to J. J goes from 2 to 3. And then we go to line 7. I is now 1, and 1 equal to 0 is false. So we go back to line 4 again because the exit condition is not met. Line 4 is recomputing the right-hand side. We have 1 plus 7, which is 8. 8 mod 5 is 3. So A bracket 3 gets a value of 2. Oop, take it back. It takes a value of 3 because J has a value of 3 now. Oh, okay. I combined 2 lines into 1. Okay, 3. Okay. On line 4, we just update I, and then on line 5, we use I to tell me which column to update. So A bracket I, which is A bracket 3, is going to be updated to the value of J, which is also 3 in this case. And then we move on to line 6, we add 1 to J. J goes from 3 to 4, and then we go to line 7. I has a value of 3. 3 equals to 0 is false. So we move on to line 4 again. So on line 4, we are adding 3 and 7 to get a 10. 10 mod 5 is 0 because the remainder of 10 divided by 5 is 0. So we put a 0 here. And then we move on to line 5. Line 5 says we want to store J, which is now 4, into A bracket 0. A bracket 0 is column E. So this is the column that is going to store a value of 4. Then we move on to line 6. We add 1 to J. J goes from 4 to 5. And then we get to line 7. I is 0. So 0 equals to 0 is true.
Wait, can you go up to the top and freeze the top so I can see the column headers?
Sure. Just, I can do this also.
Thank you.
Here we go. So at this point, I'm done.
What you said 10 mod 5?
10 mod 5 is 0. The remainder of 10 divided by 5 is 0. That's what mod does. So you have to kind of be able to kind of pull things from different contexts and recombine them in in a test. But did I change the meaning of bar A bar? Did I change the meaning of mod? Nope. It's the same thing. It's just that using those things in a context that was not the same. That is not the same as in the previous examples.
Man, you can figure this shit out.
Study. Yep.
Mod mainly means whatever divided by whatever. The remainder is what the answer is.
Mod is only taking the remainder of a division.
Okay.
Yep.
Yeah,
Right.
10 mod 5 is 2. Where did you get 0?
The remainder of 10 divided by 5 is 0. The remainder. When you have a division, we have 10 here, we have 5 here,
Yeah.
2 over here. Mod is only saying, okay, but what goes there?
Oh.
Okay? We talked about this also in class. Might be helpful to write down something.
Can you read that? Mod is the what?
Mod is the remainder of a division. It is in the notes. You gotta read the notes and study.
Sometimes I gotta hear it.
Hmm?
Sometimes I gotta hear it a couple times, that's why I asked.
Or read it a few times. Yeah, that would be helpful too. If you want to, listen to me a few times, you can watch the video again. So, you have all the tools, you have all the resources. It is up to you guys to actually do it and study. I cannot do that part for you. All right, number 3. So this one looks kind of nasty because it has got a lot of invocations, okay? But it's really, this one does not have recursion. It's not recursive. There's nothing that is invoking itself. So it's just a matter of tracking, okay? This is a matter of keeping track of stuff. So let's go ahead and trace this one. Okay, we got plenty of time to trace this one. So the test is designed, to really kind of test whether you guys understand the concept or not, and also be able to apply the concepts. It's not about memorization, otherwise it would not be open book and open notes. So it's not about memorization, but about understanding the concepts and being able to apply those concepts, possibly in new combinations that we have not seen during the test. Okay, so that's what I'm really testing in my exams. So that's one subroutine. Each one doesn't really do a whole lot, and for the most part, they're not really, that mysterious. It's just, doing stuff that we already understand. So, but this one, it really is just a matter of keeping track of, which one is invoking which one, and where's the return address, where am I supposed to go back to, that sort of thing. So ask is 5, and then we have invoke sub3. Invoke sub1. There we go. I could not copy and paste, because the one inside the browser is actually just an image. So there's no copy and paste in that case. We do all the indentations. And this is sheet 6, so we have a new one to trace it. This time we do not need comments because there are no conditions to evaluate whatsoever, so we can start with a line number, and we have only one variable x in this case, and x does not need to start with any particular value because it is going to be initialized before we use it. So the precondition is fairly simple. We don't need to know anything about x ahead of time. And then starting on line 12, which is the first line outside of the definition of a subroutine, is on line 12. X is getting an initial value of 5. And then we move on to line 13, which is the invoke statement. Okay, so this should be boring at this point because what do we do when we invoke a subroutine? We allocate the leftmost available column. Remember where it's supposed to continue after the invocation, which is line 14 in this case, the line that is logically following the invoke statement, and then continue in the subroutine starting on the first line of the subroutine that we're invoking. So in this case, since we are invoking sub3, the first line inside sub3 is on line 9, well, which turns out to be another invoke statement. So we're going to do the same thing, allocate the leftmost available column. Remember where we're supposed to go back to. Since this is on line 9 and the next line to execute is line 10, we remember line 10 is the return line number, and then we continue execution in the subroutine that we're invoking. In this case, since we're invoking sub2, the first line in sub2 that does something useful is on line 5, which turns out to be another invoke statement. Okay, and this time the return line number is line 6. Yep, go ahead.
So is the return line number always the following line?
It's whatever line that is following the invoke statement, logically. So if the invoke statement is at the very end of a while loop, in other words, you have invoke blah 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 end while, you don't want to use the line number of the end while as the return line number. You have to go back to the beginning of the loop and then use the line number corresponding to the while as the return line number, because it's supposed to go back and continue execution at that point. Yep.
But if the while was a post-check-in loop, would you return to
If it's a post checking loop, then it will be the following line, but not because it is right next to it, but because logically that's the line that you need to go to after the invoke statement. All right, so now we are invoking. Okay, we were on line 5 invoking sub1. Sub1 is the only thing that sub1 is going to do that is useful is on line 2. Line 2 is doing, okay, let's double the value of x. X goes from 5 to 10. And when this is done, we go to line 3. Line 3 is going to do two things. It will look up the rightmost active return line number and then use that return line number 6 to make a note and say, next we have to go back to line 6. And then we have no use of column E anymore. So that means we have to indicate that this column is no longer useful. And this is going to be faster when you're just writing because you can just cross it out. Now we continue execution on line 6, which is just adding 1 to x. Okay, so x goes from 10 to 11. And then we go to line 7. Line 7 is the end of a subroutine. So once again, we look up the rightmost active return line number, which is column D. It tells us to continue execution on line 10. And then we have no use of this column anymore. Indicate that is the case. And then we are now on line 10. Line 10 says, okay, let's go ahead and invoke sub2 again. Well, it's about the same thing as last time. We allocate the leftmost available column. In this case, it is column D, because column D is already deallocated at this point. So we can reallocate column D. It is the leftmost available column. So we say, okay, let's go ahead and reallocate this one. And then the line that is going to follow line 10 is line 11. And now we go to the first line in subroutine sub2, which is on line 5. And that turns out to want to invoke another subroutine, which is sub1. But before we go there, we have to remember the return line number for this particular invoke, which is line 6. And then we get into sub1, which is on line 2, to double the value of x again, which is 22. And after that is done, we go to line 3, the end of the subroutine. We look up the rightmost active return line number, which is column E. And column E.
Okay. You lost me in row 15.
On row 15?
Yep. You go return line 11. 10.
Because the invoke is on line 10, so the line that is following that is line 11.
Oh,
Okay, so this is the best part of making a trace, is I can continue execution at this point, even though there was a question that interrupting the flow. Yep.
It says, like for example, on line 3 on the left-hand side where it says end defined subroutine, does it matter if it says subroutine 1? I mean, it's saying end the subroutine that you're on. So
Yes, it is the end of the subroutine that you are defining at that point.
But why doesn't it say sub 1? Does it matter?
It does not matter because you can only be defining one subroutine at a time. You cannot nest subroutine definitions.
Okay.
Well, not in this class. There are languages where you can do that, but we don't do that in this class.
Okay.
All right. So we're back to line 3. Okay, line 3, this is really the best part of tracing. I mean, there's no better demonstration than this. Because, if I were not, writing down everything in a spreadsheet and I get all these questions, then I would have problems remembering, but where were we? Where am I supposed to do at this point? Well, guess what? We are on row 19 of the trace and I know exactly what I need to do. Because on line 3, which is an end defined sub, it doesn't matter which subroutine you're ending. You still have to do the same two things, which is look up the rightmost active return line number. In this case, it's column E. It's telling us to continue execution on line 6. And then we have no use of that column anymore. So we deallocate it on line 3. We are back onto line 6. Line 6 says, add 1 to x. So it now becomes 23. And now we move on to line 7. Line 7 is end defined sub. Look up the rightmost active return line number. It is now column D. It tells us to continue execution on line 11. And then we have no use of that column anymore. And now we are back onto line 11, which is another end defined sub. So we have no use. First of all, we look up the rightmost active return line number, which is actually column C at this point. It tells us to continue onto line 14. Make a note of that. And then we have no use of column C anymore, and then we continue execution on line 14. Line 14 is another invocation. Fortunately, this time it's invoking sub 1, so it's not going to be as big of a mess. So line 14 is invoking sub 1, so we're going to do exactly the same thing. allocate the leftmost available column. Tell me which one is the leftmost available column.
First
C.
one.
Column C. Column C is the first one, or the leftmost. So we reallocate column C, mark it as return line number, and then where are we supposed to go back to after this equal? Post. Exactly. And then we continue execution on the first line of the subroutine that we're invoking, which is line 2. Exactly. Line 2. Line 1 doesn't do a single thing. We do not trace line 1. Yep.
Go ahead, I'm sorry.
That's okay. So we double the value of x, so it becomes 46, and store it back into x, and then we go to line 3. We look up the rightmost active return line number. We only got one return line number at this point, which is column C. It tells us to continue execution at post. Make a note of that, post. And then we have no use of that column anymore. Allocate, make sure that we deallocate it, and then we continue here, which means we are all done.
How did you get the value 46 for x?
Because on line 2, we double the value of x and then store it back into x.
So it's x plus x.
Yes.
Okay.
Okay. So are we okay with this one? It uses it dynamically allocate up to 3 columns, and then the final result of x is 46. Okay, but to make it so that you can at least get partial credit, this is the way I am asking that question. I'm not asking for the final answer, because to get through all of this to get to the final answer means you cannot make a single mistake in between. So instead of doing that, I'm asking you the values of x immediately after the following lines. And if it does visit a certain line multiple times, you have to tell me the first time is going to be this value, the second time is going to be this value, and so on. So that way, if you at least get part of the trace right, or if you only have enough time to go through half of the trace, you will get partial credit for this question. So I still give you partial credit, even though I'm also at the same time trying to make it easier for myself to grade it, because I don't need to look at the entire trace, but you will still be able to get partial credit if you don't have enough time to finish it.
Can you go over what you'd be expecting for the answers here?
Absolutely. So in this case, I'm asking you what would be the values of right after line 9 executes. So what you can do is to look at the trace. Okay, let me just display both at the same time. So you can look through the trace here, and you basically say, okay, after line 9, which is the invoke statement. So that means, right after that would be when we get back to line 10. Okay, but right before, let's see, how should I put it? Okay, this is line 9, but this is not when we are done with line 9. I guess that's a really poor way of putting it. I should probably put some extra like stupid statement in between and ask when we get to that statement, what is the value of x? So that would be a better way to ask it. Thank you for that. But that's basically what what I'm asking in this case would be, this is the first time we get back onto line 10. So x has a value of 11. So you want to put 11 here, but then we get back to that also. Well, we only get back to that once, because we only invoke sub 3 once. So on line 9 is just 11.
Why
And then,
11?
Yeah, it's like the same thing then, right?
say again?
So would it be the same answer between line 9 and x and line 10 and x?
No, because wouldn't you invoke sub 2 again, so it would...
Line 10 would be here. Line 10 would actually be have a value of 23.
So what he was saying is that the question is asked weird, because really what you want to know is after you've gone through all this and you've invoked
Right.
sub 2, then you want to know what x is.
Yeah,
When I
I think.
strike through and come, okay. Gotcha.
Yeah, I think in the test, I'm going to change the form of the question. So instead of asking that, I'm going to put some, like empty statement here. And I'll call this like, 9.5. And this is 10.5. And I'll be asking you, what would be the value of x, on those lines. That makes it more clear. So when you get to line, 9.5, what is the value of x? When you get to line 10.5, what is the value of x? I think that makes it more clear.
So
What is it?
can you?
It would be 11 and 23.
You got confusing now.
Hmm?
Because you're saying the answer, like 9.5, the answer is gonna be you invoke subroutine 2, and then after you're done with that, then 9.5, that's the answer.
Okay, if we do have a line 9.5, that means, this is now line 9.5, right?
Yeah.
So instead of returning to line 10, here,
That's right.
oh, wait, hold on. Okay, this is 9.5, so we get back to here. So I have to insert one more row because we are getting to line 9.5 here. So the value of x will be 11 first time. Is that okay? And then with line 10.5, that means we don't have a return line number of 11 anymore. So instead of 11, it becomes line 10.5. So when we get back onto line 11, we are actually getting back onto line 10.5. So this becomes 10.5, and at that time x has a value of 23. Yep.
But can you just put all the exit values and then pick like as many right we got?
Say again?
Like let's say you got certain S values, so why can't you just count them as many as we got right, and then instead of what's the line number or whatever. Let's say we got.
I need you to tell me the value of x only on certain lines because I need to know that you can follow the flow of the algorithm correctly. Because I don't want people to play lotto with me.
Huh?
X can have these values during the execution of this program. I'll just pick some random numbers and hope that some will hit the actual answer. So I don't want people to play lotto with me. I want people to tell me exactly at what point x has what value. Yep, go ahead.
Well, I think from what he was saying is instead of us having to write down the x, why couldn't we take it from our trace? Because during our trace, we're showing.
You still need a trace. You still need a trace to do it, okay? But I'm not asking you to turn in the trace. Yep. Okay, we got 3 minutes left, and we'll take a look at the last question. We may not have enough time to actually do it because this one is actually a little bit longer. This one is. Okay, I give you an array of 3 elements, so we only have to go through the loop how many times? Okay, let's just analyze this part. Okay, with 3 minutes, I can at least explain that much. I is initialized to 0, so we are starting with 0. As long as I is less than bar a bar minus 1, I will go into this loop. But bar a bar is what in this case? Bar a bar. I spelled it out here. There are 3 elements. Okay, 3 minus 2 is 3 minus 1 is 2. So as long as I is less than 2, we go through this loop here. For each iteration of the loop, I invoke ABC. So let's forget what ABC is actually doing for the time being. But for each time we go through the loop, I can increment by 1. So the first time we go through the loop, I has a value of 0. The second time we go through the loop, I has a value of 1. Do we have a third iteration?
No.
No. Okay, so we only have to go through the loop twice. So the real question is, when we invoke ABC, do you know what ABC or subroutine ABC is actually going to do? Well, it is comparing the 2 elements to decide whether to go through the code in between the conditional statement, on lines 3, 4, and 5. So you can probably trace this one, and figure out, try to figure this one out by yourself. And then when I get home, I'm going to record the answer of this one and post it onto YouTube, so that way you have the extension of this class, on YouTube. If I don't do that by tomorrow night, you'll just send me an email and remind me to do that. It shouldn't take me long to do it. Take me a few minutes. Yep.
Can you also to the last one that you traced before that, and you had to change everything to the 9.5 and the 2.5?
Yeah.
If you can change the answers also to reflect that and the trace to reflect that.
Okay.
So that makes a little more sense because you kind of switched it up. So.
Yep, I did.
I'm sorry, because
That's
I'm not
okay.
able to look at this really and see exactly what x would be after line 5 and 2. So are you meaning?
Okay. Line 5 is different because we are going to
already
line
in a
several
subroutine.
times.
Yeah, we are. There's several. So we're exactly.
Okay, so let me save this first because this one I need to save.
Okay, so this is line 5, right? Here?
Yep, that's line 5.
So where
So that means,
exactly?
kind of imagine that we have a line 5.5. So that means that every time we hit line 5.5, what is the value of x? That's what I'm asking.
That's the thing I don't know. I don't.
Well, if you look
Say-
through the code, look through the trace, so, well, I didn't have line 5.5, in the trace, but basically
It
it's
would be
every
like
time we
right
get
in
to 6.
here, right?
Yeah, it will be every time we get to 6. So x has a value of 10 when we get to line 6 the first time. See, because
Oh, I see.
yeah, because line 5.5 would come in here.
Yeah, but then we also go to 5 here, so you
Yep.
just want
So
to.
that's also 6 here. So the second time, so the first time is not. The first time is it has a value of 10. The second time it has a value of 23. 22.
So where are you looking for 2 answers then?
Yes. In that case, it will be comma separated. So it's
Tricky.
Yep, because I am asking you each time we get to that line, at the end of that line, what is the value? So instead of asking you that question, I'm gonna give you guys, like blank like these, so that way it's very clear. When we get to here, the value of x is blah.
23, and then when you hit 2, so like this one would be actually like here then, right? Like 2.5, so 10, and then 22.
10 and 22.
Okay, thank you.
You're welcome.
Professor,
Yep.
I have a question.
Sorry.
Son, I'm teaching for summer.
I'm not teaching in the summer. I'm taking the summer off.
Yeah,
If you
but-
want to take CISP 360 in the summer, I think your only choice is to take it from Dixon.
How's Dixon, you know?
I have no idea.
Yeah, sorry.
So you will have to do your own research.
I did the research and it's not that good. I mean, read my professor, it's 2.5
Uh-huh.
out of 5.
Well, you have to take that sort of thing with a grain of salt,
You're teaching it on the fall, right?
I'm teaching the same class in the fall.
Then I would in the fall.
But you said
Okay.
you're doing a 360
Hmm?
in the fall.
I am teaching 360 in the fall.
Alright, cool.
Alright, Professor.